The inclined plane is going to be the next situation that we look at. I'm doing some general pictures first for you. We have to draw out 4. We'll draw them real big and we're going to give them explanations. So it's probably going to take 2 full pages to do this. And as long as you kind of know what's going on for the general pictures, all you have to do is identify what kind of inclined plane it's going to be for your question, and then just remember back to these pictures. Okay, so we're actually drawing 4 pictures, but there's 3 general things that are going to occur for the inclined plane, and I'll explain what the inclined plane is as I draw this first one here. First situation, the inclined plane does not accelerate. Okay, so it does not accelerate. That's our first little point, and our second point is it has got no applied forces in here at all. No applied forces, which means no ropes or anything like that. Okay, that's what my first little point is. Now, an inclined plane, generally speaking, is just a wedge. So if you remember from 30S, you took a board, you put a couple books under this side here, you pushed it up at some sort of angle, there. And we are going to take a box. We don't really care what the mass or anything. We don't care about the mass of the box or the angle of the inclined plane. They're just general situations right now. This does have a mass, so it's going to have a whole bunch of forces. It does not accelerate, which means that we have constant velocity. Okay, so what we'll do first before we start applying any forces to actually make this thing not accelerate is we're going to, out of the center of mass for this box, we're going to come down with this vector. This is the force due to gravity vector. Okay, so that's your FG downward. This force due to gravity really doesn't do us any good because the axis that we're going to want to use is actually going to be this. We're going to like to use that as our x-axis. So almost we want to think about this as being our horizontal. Okay, so that's going to be x and this is going to be y. But I'm not going to draw it like this. I'm actually going to put it back straight this way, and I'll just rely on you to be able to figure that out. So our F force due to gravity is going to have a y component down, so that's going to be Fy. It's going to have an x component here, that's going to be Fx. This will be theta. Okay, this angle here is going to come to this triangle, and that force, here I'll put it this way. Actually, I'll flip it all the way around like this so that you can see this triangle that we've just made here. You notice here that we have our force in the y direction is actually on the adjacent side. And adjacent is usually cosine, or it is always cosine, and adjacent and cosine usually attached to an x, which is way over here, but our y is attached to our cos, so that means our x here is going to be attached to our sine, which is our opposite side. That is going to be one of the things that we're going to look at way later on. We're just drawing a general picture out for now. If this force in the y direction is the y component of Fg, then this is going to be our normal force, so that's going to be Fn. And now what we can do, we're going to take this Fx, since Fx is the only thing that's pulling this thing down the incline, that's going to be your Fx, and since it's trying to go down, but it won't be allowed to go down, you're going to have a force of friction that is going to be opposing this whole situation. So there, that's your general picture, and really all you need to remember with this one is that Fn is equal to and opposite to, or equal and opposite to Fy. Fx is going to be equal to Ff. Okay? That's your very first general situation. That is about as easy as inclined plane gets. For a picture anyways. We're not going to do any numbers right now. We'll get to the second picture. In our second picture, we're going to have the object will accelerate up the incline. Okay, so now we have acceleration up the incline, which means to accelerate up the incline, we're going to have an applied force. So we're going to have an applied force upwards. And when I say applied force, I mean like a rope or something. So we'll take our incline again. There's our general picture. There's the box. We know force due to gravity pulls down. So then we know that that's Fy. We know that this is Fx. We know that this is Fn. We know that Fx goes here. Okay, so that's all the information we have, but now this thing accelerates up the incline, which means you have to have a rope with some sort of applied force pulling it up. It doesn't want to go up, so friction is going to be pointing downward, force of friction, which is trying to oppose that. So what we're saying essentially then is your applied force is going to be greater than your force in the x direction as well as your frictional force. So this is bigger than those two, so it goes up the incline. And this is theta here. Okay, that's 2. For 3, I'm going to need a brand new piece of paper because it's 2 more pictures. For 3, it's going to accelerate down the incline. Okay, so there's our first point, and it's also going to have an applied force. So for our first one, it accelerated down the incline, fine, but now we have a rope on our inclined plane, and so that means that we're going to have 2 pictures, because we can have 2 situations where we accelerate down with an applied force. So for our first one, there's our theta, there's our box, force due to gravity, force in the y direction, force in the x direction, normal force, and Fx comes here. Okay, that's everything that we know. Now, if it accelerates down the incline, we have 2 possibilities. 2 things can happen. The first thing that can happen is that we can have the applied force pulling up. Actually, I'm gonna, this is too bad, I've drawn the vector too big here because it looks like this is a huge force. But that's okay. Because if this thing is applied upwards, but it's still accelerating down, that means that Fx has got to be bigger than Fa, and your force of friction has got to be trying to oppose that. So what we have then is that our Fx is greater than Fa plus Ff. Okay, and this thing's going to accelerate down. So accelerates down. So really what you've got is a rope attached to the box. The rope is trying to pull it up, but the box is too heavy, so the x component of gravity keeps on pulling it down anyways. For part B, or your second step, you're going to still accelerate down the incline. Except this time your applied force is down. So let's draw that out. There's theta, Fg, Fy, Fx, Fn, Fx comes here. Now you have an applied force that's down, which means you also have an applied force this way. And your force of friction is trying to oppose the downward motion. So there you go. And really what's happening here is that Fx plus Fa has to be greater than the force of friction. The 3 types of inclined plane problems that we'll do, they are tricky, but once you've drawn them out a few times, I think the picture will be okay. So there's that first page, or sorry, that's the second page, and here's the first page. So you've got lots of drawings that you're going to have to do, and they're all pretty well the same drawing. There you go.